Have you gone through the last session and assignments?
Yes.
Any doubts?
I have one doubt in in associative array where we need to declare the class type array, data type of class type. So in that I tried, but I'm getting a error in that.
Data type of class type. Okay.
Uh, After class, I'll share my code to you and the question if you.
Okay. So associative array you are writing in the class. When you are declaring that star, one example I have shown you int also in brackets. In one
Yeah,
example.
into one it is into ones are I mean it is fine. I mean I'm not getting error. Int and string type I'm not getting error. But when I'm doing a class type, it was showing me the error.
Okay.
I am also getting some error, like in the first assignment where you mention one code to write where data type like that. So I try to write a code using where data type, but there error is coming due to this. Like when I use logic, no, it's working fine. But when I change the data to where, it's not working. Like it's because some error is coming there.
In system Verilog, wire will not work.
Okay, but ma'am, you said that assignment, no, there are only one like problem statement is like that key you need to write a code using where data type like that. So it's not like a problem
Okay.
statement of system
Whenever
Verilog.
you get the doubts, just share in the group. You are not sharing anything in the group. How can I check all this?
Okay,
Whenever
okay,
you get the doubt, share EDA link in the group. Okay. And also this Saturday, in Saturday session, we will discuss how to install the tools, QuestaSim, how to write the program.
and whatever in your PPT is present, no, they are the mostly system Verilog for written in main program using the program main like the starting. But
Mm.
also using module also we can do, na,
We
like
can
same.
use module also. We connect test bench and design. For that purpose, we use program block. But for program block also, we have lot of limitations. I will discuss that thing in a OOPS concept once we started OOPS. That's why I didn't explain. So, program we don't use practically in test benches, but by using program we can avoid the race condition between interface. I mean, the connection between test bench and design. Okay, both you can use module or program.
Like I got a mini doubt, but like I'll ask in the group only, like when I share the link over there because now.
Yeah, share errors, share in the group. I will check.
Okay.
And if it is small thing, I will write in a group only. But if it is something we need to discuss, means I will explain in the session.
You Prasanti.
Shweta, to do, are you able to write the program?
Yes.
Okay. Concept, fork join and mailbox. Today we will discuss semaphore. Did anyone gone through this topic? What is mean by semaphore?
For example, if number of CPUs are working together and they are sharing one their process, then one by one, like they took the semaphore to come. One CPU will complete the process, and after completing that, that one release the semaphore, and second will acquire that. Like that, it is a kind of a for a synchronized purpose. We use the semaphore.
Okay. Any other answers, others? What is mean by semaphore? Okay. Mailbox concept clear, everyone? Any doubts in the mailbox? Okay, semaphore is nothing but where we run multiple number of tasks. Okay, based on mutual exclusive. Like suppose to run multiple number of tasks, we need to set some limit where we cannot run all number of tasks at a time. We need to give the access, okay, to each task, which one need to perform first and which one need to run next, like that. Okay, we will give a key. We call it as a key. Okay. So suppose uh, there is a car, okay, and four persons need a car, okay. One person want to go some um, any direction, north or east, whatever, with for some buying vegetables or for grocery, just want to go to market. And person two want to go for vacation or any just a small trip. And person three is a emergency, some hospital, like that emergency case he want to go. And person four maybe some for friends house or relative house, like that, okay, for any urgency or just some priority two case, okay. But only one car is there, okay. So first, who can use that car? Means based on the small distance first, which can be completed in a 10 minutes or half an hour, okay. First priority will be given to the less distance person, okay, because he or she can complete within half an hour. Or else emergency case, first priority will be the emergency case, okay. So the key is getting for this person first, the car key is getting for this person. They can do their own work, okay, uh, taking the key and using the car and doing some work, whatever the emergency is there, uh, that is completed, and giving the key back to the car, okay, just putting there. So the key is available now, okay. Second, any other person can use the car, key is available, right? Any person can use. Suppose market is within half an hour or 1 hour it will be completed, right, the task. So the priority will be given to this person, okay. So he or she can use that key and do their task and returning back the key, okay. So person 2 task also completed. Now person 3 task. So going to friends, uh, like relatives or friends, whatever. So this will be the third person priority, third priority, taking the key and using the car and returning back the key. Now key is available again. So that fourth person, whatever the fourth task is there, that task can utilize the key. It can get the key and utilize the card. And after the task, it can put in the card. Okay, it can just give the return back the key. Okay. So four tasks are completed based on the priority or based on the less distance, less time, like that. Okay. So same case, if there are two number of cards, that means two number of keys are available, two cards are available. So what happened? Two persons can use at a time. One person one card, another person another card. Two number of keys. So now the time will be also less. two things can be done at a time, right? So the time will be saving. Okay, so this is what the semaphore concept. This is what the semaphore concept, where we have the multiple number of keys, and whatever the priority task is there, we can access the keys and we can do the task, and after completing we can return back the key. Okay, in the same way, there are in real time, suppose if we are writing the program in System Verilog, there are multiple number of files. Okay, so there are multiple number of tasks, task 1 2 3 4. So based on which task can do first, and which task can procure the key, and which task can return back the key, like that we need to write the functionality. Okay, so this is what simple concept of semaphore. Everyone understood? Based on mutual understanding, suppose here friend market is the second priority, but maybe this relatives meeting or friends meeting may be highest priority. Based on their mutual discussion, this task may be done second, and this task may be done third. Okay, so it totally depends on mutual, and also a time emergency, like that. Okay, clear everyone, conceptual wise? Not
Yes,
clear?
ma'am. Yeah.
Yes, ma'am.
Okay, now how can we write a program? So if you read here, conceptually, a semaphore is a bucket, where a semaphore is allocated a bucket that contains a fixed number of keys. Keys may be any, like one it may have, or two, or four, or six, or 10. Okay, based on number of keys, we assign number of tasks. After completing the task, they need to return back the key, and that key can be used by any other task. Okay, if we have key, then only we will get the access to do that task. That's why key is important here. So only a fixed number of occurrences of that process can be in progress simultaneously. All other must wait until a sufficient number of keys are returned to the bucket. Okay, if there are no sufficient number of keys, then need to wait. Suppose in bucket 2 keys are available, but that task require 4 number of keys. We can use multiple number of keys also, not only single. Okay, if the task requires 4 number of keys, means it need to wait until it get 4. Okay, meanwhile that 2 number of keys can be used some other task. Okay, so semaphores are typically used for mutual exclusion, access control, to share resources, and basic synchronization. So what are the methods we use mainly in a semaphore? Means new method. We already created mailbox. Mailbox we have created using new only, right? Like that semaphore also we create using new. Next, put, get, try, get. Have you tried with these methods, try, put, try, get? I have shared the assignment also regarding that. Okay, see here example. Program main semaphore. Semaphore is a keyword. Sema is equal to new of 1. There is only one key. Okay. Initial, begin, repeat of 2, begin, fork, begin, display, waiting for fork key. It is waiting for key to do the to do some task. Okay, so key is available in the bucket. That means key is available in the sema. Okay, so sema dot get of 1, getting the key. So it got the key and doing some task. In this task, you can write anything like addition of 2 numbers, or any multiplication or logic operation, whatever. Okay, you can do some work, and after completing of that, put back into the sema. Okay, so sema dot put of 1. Now key is available here. Okay. After returning back the key, now process 2, second process, is waiting for the key, and now it got the key. Get off 1, that means got the key. It doing some task with the key and putting back into the SEMA. So returning back the key and join. Here we have written fork join. Fork join means that means all processes will start at a time. Okay. Process 1, process 2, everything will be started at a time. But based on the availability of key, they will get the access to do the work. Okay. We'll run this program. Already I shared the assignment for semaphore also. Just try.
Hi, ma'am. I have a doubt. Like semaphore and mailbox purpose is same, right?
No, not same. How it is same?
Like the purpose is to send the data from generator to driver.
Is it sending to generator to driver here?
No.
Then
Okay.
how it is working? What is the difference?
Here, at a time, we can send one based on the priority, right?
Okay. What is the
Whereas
concept of mailbox?
mailbox, in the sense, we will send the instructions or data from generator to driver.
Okay. Okay. So mailbox is a communicator. It's just a communicator between generator and driver. Whatever we are generating the data, we are not sending directly to the driver. Why? Because synchronization purpose, both frequencies are different, right? So to store the data temporarily, we are using the mailbox. We are storing the data into the mailbox to store temporarily. I also asked the question, why don't we use array? Why don't we use queue? Why we are using only mailbox? Did you got that answer? Why don't we use queue instead of mailbox? Did anyone try that? Why don't we use queue instead of mailbox? Because mailbox is a component to component. Externally we are connecting component to component, but if you connect internally, there we use a queue. Okay, but mailbox means external connection, that's why we use mailbox. Okay, but coming to the semaphore, it is not communicator, it is just giving the access to the processes for different threads. It is giving the access to complete the functionality. Okay, without completing all threads at a time. So which can do first and which can do second. If there are more number of instructions, we are just allocating some time, or we are just allocating some priority wise task, like that. Okay, so here if you observe program main, I explained the program, right? Just run and check what is the output. Can you tell me now which statement will first will print first and next?
Process 1 will be executed at first.
Okay, process 1, which statement?
The first one waiting for the key.
Okay, next.
After 10 time units, returning back the key.
After wait for key, it will directly return back the key. Yeah?
No, ma'am, like it will do some work and it will put back the key.
Without getting the
Then,
key, how it will do the work?
yeah, sorry. First, waiting for the key, then get the key and do the process and putting back the key.
Okay. Next.
And process 2 will start after process 1.
Okay.
Waiting for the key, get the key and do the process, put back the key and return the key.
Is this correct, everyone?
I think first it will display waiting for the process one, waiting for key. Then for the process two also, it will be waiting for the key. It will print.
Okay.
And then uh, uh, process one will get the got the key. It will display.
Okay.
And it will return back the key. Then process 2 got the key, return back the key.
Okay. Others, any answers? Is this
Ma'am,
correct?
I
first,
think okay.
Hmm.
so ma'am, first would be the waiting for the key,
Okay.
and ma'am, can you go up, please? There is any fork join? Yeah, so this is the fork join. So waiting for the key will start, and then also for process 2, the waiting for the key will start, and then after 10, and also then the got the key after and got the key will be got the key will print at the same time unit. Then after 10 time unit, the returning back the key, and for two process 2, returning back the back key will happen at the same time unit.
Okay. So here we are using the fork join concept. Fork join concept means a thread 1, thread 2 will run parallelly. So thread 1 is waiting for the key and the thread 2 also waiting for the key. Both will run at a time. This is wrong. Who said this answer? So here process 2 will wait and process 1 also wait at a time. But here process 1 will get the key because it is a faster, written faster. And then it got the key, do some work, return back the key. Once it is returning the key, second one will got the key because already it is waiting for the key. And after getting the key, it do some task and return back the key. So this is what the format it will print. What is the other? Okay, I'm removing this. Waiting for the key, got the key. See, second one also waiting for the key, and first one returning back the key, and second one got the key, and second one returning back the key. Again, process repeat. Why? Because here we are writing repeat of 2 times, process repeat of 2 times. So second time again repeating, process 1 will get the key because process 2 return back the key is available there. Okay, suppose there are 2 number of keys in the bucket. Instead of 1, I am just putting 2. Okay, now what will be the output? Now what is the output?
They both run parallelly.
Okay, so semaphore 1 and 2, both processes will get the key at a time. So they work parallelly. Both tasks are done parallelly. See here, first one waiting for the key, got the key. Parallelly, second one waiting for the key, got the key. And first one return back the key, and second one also returning back the key. And process repeat. Okay. Same, suppose if first one is accessing 2 number of keys. Okay, so it should wait, it will do the task, and second one need to wait until 2 number of keys or 1 number of key at least available in the bucket. Okay, now run and check. Okay, see, waiting for the key. Okay, got the key. Second one also need to wait the key because whatever 2 keys are there in bucket, the second one access those 2 keys. Here you just mention as a 2 because it's accessing the 2 number of keys. Okay, and then first one returning back the key, second one got the key, and also it do some task and returning back the key. Again, first one is waiting for the key, second one also waiting for the key. Second one got the key. Okay, see, second one got the key. Okay, okay. Here, second one is returning back the key. Okay. First
In
one
I
is
think
waiting for the key. Second one waiting for the key. Already 2 keys are available because here second one is returning the key. Then why first one is not able to access those 2 keys? Why second one got the key?
input in the process one, there is a put in that.
Okay, put 1 only here. It is putting. Okay, okay. Here it kept only 1. It's an only 1. That means already another is the process 1 here. That's why in the second time, here 1 is still waiting for the key because 1 didn't return the key in the first process. Okay, so here second time again it is not getting. Why? Because first time 1 is not returned 2 keys. That's why here it is waiting the key. Whatever the available key is there, that is going to second one. Okay, again second one got the key and returning back the key. Here why it is not getting means there is only 1 key, because here it send only 1 key. Suppose if I put 2 here, now here it will wait for the key and it will get the key. Okay, just run and check. See, second time it wait for the key and got the key. Now 2 are available. So here second one waiting for the key and first one return back the key. Then only second one will get the key. Okay, clear everyone till here?
Ma'am, can you please explain once again?
Before one, have you understood before example?
Yes. Yes.
Here, before what happened means only 1. Here 1 is there. That means what? Here in first process, in repeat 1 time, first process, 2 keys it is getting. First one, first process 1, 2 keys it is getting. That means in bucket there are only 2. Okay, it got 2 keys. It done some work, and how many keys it is returning back? Only 1 key it is returning back. It have another 1 key. Okay, so now process 2. Process 2 need only 1 key. So whatever available in the bucket, 1 key it is taking. Process 2 is taking and it is doing work and it is returning back the key. Okay, so now only 1 key is available here. Already 1 key is left here. Process 1 already using 1 key. It forgot or whatever I forgot here to do. But internally system will understand, like by using that 1 key it is doing some task, right? So already it have 1 key. In again repeat 2 times, second time repeat, it asking for 2 keys, but there are no 2 keys, right? 1 key already before in repeat 1 case it already have. Now in the bucket there is only 1 key. So now here 13th line it doesn't get the key, so that is going to second one is getting the key. That's why before we got this output. I'm showing the output again. So here in second process, second time repeater, waiting for the key, and second one got the key. First one didn't got the key because only 1 key is available. It forgot to return the key. Suppose if I am putting 2 here, so in the first case only it returning back 2 keys. So second process will access 1 key and it will return back the key. Again first one can access those 2 keys. See here, first one waiting for the key got the key, and second one waiting for the key, and first one return back the key and second one got the key. But before it is not same, right? Did you all understood now?
Yes, ma'am. Yeah.
So like that you can use 4 number of keys, 10 number of keys based on number of processors, number of processes, and the number of tasks. You can allocate each key for a task, or 2 number of keys for a task, or 3 keys. Okay, just do practice these examples. So that is what semaphore concept. Next, mailbox completed. Events we will discuss later. Now we will discuss interface. What is mean by interface?
It connects design with the test bench.
Okay. It just connect the test bench to the interface. So in Verilog HDL, how we connect a design and a test bench?
We will use the design module in the test bench. For example,
While
it's
creating a handle by creating a handle for the design.
Okay.
Instantiation.
Instantiation. Okay. But in coming to system Verilog,
Interface.
okay, so in Verilog HDL, normally we will connect design name to in the test bench by using DUT and we connect the port list. Okay, but in system Verilog, we have separate interface file to connect the test bench and the DUT. Okay, so in Verilog HDL, whatever we are connecting, just we'll connect manually. Suppose if you see the interface concept here, the communication between blocks of a digital system is a critical area. In Verilog, modules are connected using module ports. For large modules, this is not productive as it involves manually connecting hundreds of ports may lead to errors. Detailed knowledge of all the port is required and difficult to change if the design changes and more time consumption and most port declaration work is duplicated in many modules. Okay, one thing is a manually connecting. Next thing is here we are connecting driver to DUT to monitor. So in that case, a lot of synchronization is important. Driver to DUT to monitor synchronization is very important. So in system Verilog interface, we write the clocking blocks. And also we write the mode ports. Mode ports are nothing but to make the ports synchronization purpose. We use the mode port concept. Okay, so we have some advanced concepts in interface here. And that too, in Verilog HDL, whatever we are connecting manually, it's a static interface. But in system Verilog, everything we use the class-based verification, right? Classes, objects, right? So static interface we cannot use. We need to use virtual interface. So in system Verilog, virtual interface concept is very important. And that too, it's a most asked interview question. What is the difference between interface and virtual interface? Why do we use virtual interface in system Verilog? Why not normal interface like physical interface? Okay, so see here, interface construct, the test bench to design. This is how we connect in the normal Verilog, right? Without any interface. Directly we connect whatever the signals out there like address, enable, write, enable, read, data, read data, directly will be connecting. But in system Verilog interface, we connect all these in a bundle. So interface is a bundle here. In that every port list we will mention. Okay. So how to write the interface? If you see here, syntax. Interface is not a class, it's just a keyword. Okay, we write like interface and interface, like module and module we write. Right. So like that interface and interface, we need to declare the name of the interface. Within the interface, we need to write the all input and output variables, and also how we are declaring the input and outputs in Verilog test benches by using reg and wire data type, right? But here in system Verilog, we don't use reg and wire data type. I already told why it is. We use the logic data type to avoid the confusion between reg and wire. We don't need to use two different data types here. So simply we use the logic data type. So that logic declaration we do in interface. Most of you confuse where we need to declare with the logic. Some of you will do in transaction class. But in transaction class, we need not to declare the variables with the logic. In interface only, we need to declare the variables with logic. Okay. So after declaring the variables, you can write the clocking block, you can write the mode ports. I will show you how to write those also. So if you see here, advantages of interface over traditional connection. It allows the number of signals to be grouped together and represented as a single port. The single port handle is passed instead of multiple signals or ports. Interface declaration is made once, and the handle is passed through the module or components. Through the handle only we need to interact with all, right? Whatever the generator uh, variables or their transaction variables or their everything, we need to connect with the handle only. And addition and deletion of signals are easy. So how to write the interface? This is what manual, like in Verilog HDL, however we write that one. Suppose left side one is a design, module, memory, clock, address, write, read, write data, read. So some operation. Right side is a interface, like how you are connecting. Inputs are declared with the rich data type, outputs are declared with the wire data type, and we are connecting with the DUT instance. Write the name of the design and instance for the design name, like a DUT or any name you can write, and also putting the port list, connecting the test bench signals with the design signals. This is what normal interface. But coming to the system Verilog interface here, if you see, design, memory, same design before, however we write, and down interface and interface. We are writing within the interface and interface. Name of the interface is mem int f. In that, all variables are declared with the logic data type, and right side one is a normal top level connection. So this is how we write the interface syntax. Interface, name of the interface, in that we declare all the variables. And down, if you see, creating the instance of interface, int f I. The I is the instance. So if you want to access A, B, C variables which are in interface, you need to access through this I only, through this instance name only. Okay. Int f is the interface name, but instance name is I. So ii.a, ii.b, ii.c. That is what the path. Okay. So you will get more detail in object oriented program. So if you see here how we are connecting in DUT dot A, this dot A is a design, but test bench A is ii.a, that is what test bench variable, and dot B is the design variable, ii.b is the test bench variable, and dot C, ii.c is the test bench variable. Okay. So accessing interface signal, A equal to 6, B equal to 4, some names, values assigning to A, B, and C is equal to A plus B, displaying the statements. Okay, so this is how we create the simple interface. Everyone understood till here?
Ma'am, I have a doubt. Like this dot instance, we don't write in the interface block, right?
Not in the interface.
Okay. Yes.
Interface, where we connect interface in top level. In test bench architecture, if you see, suppose generator, driver, monitor, scoreboard, top level is environment. For environment, top level is test. Like that for interface, what is the top level? Check the test bench architecture.
Okay, I'll check it.
Everyone? Have you checked? Where we run the interface in system Verilog test bench architecture.
On top, we will instantiate DUT test and interface.
In top level test bench, main test bench. Huh?
Yes,
No,
ma'am. In test.
in top only
In
we
test.
Tell. Only in top or top level test bench? Huh?
only in top.
In top, huh? No. Then where we run test? Test and interface both will run in test bench. Top level test bench, not in test. Interface, this is the interface block. Cal if and test. In test we run environment. This test and that interface both will be run in the top level test bench. See here. Test and interface, both files are included in the test bench. Here we run the, so if you see here how we are connecting the DUT here in top level test bench. This out data one is the design variable. Data out one, out data one, out data two. These all are design variables. And calci if out data one. These are interface variables. So if you see here the example, however, ii.a, ii.b, ii.c. So calci if is the name of the interface. So we are connecting with that. Okay. Calci. Clear? Any doubt still here? And we are running the test, top level test here in the main test bench. See here, circuit diagram. This interface, green color one is the interface, green color test. These two green colors are going to run in the test bench top. In test bench top, we need to put environment, we need to put in the test. Generator driver scoreboard monitor in the environment. Okay. Next, why do we use virtual interface? Before virtual interface, I will explain this interface block. Okay, I will explain the virtual interface first. So what is meant by virtual interface? Before we have created the interface class, right? So it is static in nature. If you want to access the variables from DUT, we cannot access using the interface. So that's why we need to create the virtual interface. How we create the virtual interface? Whatever the name of the interface is there, right? Before example, calci if. For the calci if, we will take another instance. We'll create another instance with the name of virtual. So virtual calci if some interface name, virtual interface name, VIF. Through that VIF, we can access all the variables of DUT, driver, monitor, transaction data, everything we need to access through that virtual interface only. Okay, so see here how to create the virtual interface syntax. We need to please mute everyone. We need to create with a virtual name and name of the interface and instance name. So like this, virtual is the keyword, int f is the name of the interface, vi is the name of the virtual interface. Okay, now whatever the variables you are accessing, you need to access with the vi only, not with int f. Okay, so here if you see the question, what is the need for a virtual interface in System Verilog? Means System Verilog is interface is static in nature, whereas classes are dynamic in nature. Because of this reason, it is not allowed to declare the interface within classes, but it is allowed to refer to or point to the interface. It can point to the interface, and through that path we can access the variables, but directly we cannot put. Okay. So a virtual interface is a variable of an interface type. It's just a variable. Okay, just an instance that is used in classes to provide access to the interface signals. Clear till here, everyone? Any doubts? No doubts? Okay. Next.
Ma'am, I have a doubt.
Yeah.
Can you go back? Uh,
Okay.
I mean, ma'am, here it is written like interface. It is static in nature and classes are dynamic. So we are not using declared interface within the classes, right? But again, it is written like a virtual interface is a variable interface type that is used in classes. Means we are using a virtual interface so that we can use it inside the classes, right?
Yes. We use interface inside the classes only. But interface we can't use inside the class because it's a static. Okay, it cannot work with the class. So for that purpose, we are creating in virtual interface extra. I will show you. Okay, through that virtual interface instance only we can access within the class.
Okay.
Normally
So
we need
ma'am,
to put interface, but interface we cannot put. That's why we are creating the virtual interface.
so that virtual interface is not a static in nature.
No, not static. It's dynamic. We can access
Okay.
the objects, classes using virtual.
Okay.
Okay. Next, this is what interface and also class environment, how we are creating the virtual. Virtual is a keyword. Interf is the name of the interface. VIF is the name of the virtual interface. Now, whatever the A, B, C valid signals are there, variables, those variables you need to access with the VIF only, not with the int f. Int f is the instance of interface. VIF is the instance of virtual interface. With the VIF only, you need to access those variables. Okay. Next, creating the function. Next task run VIF.a is equal to 6. How we are accessing a, b and assigning the values. VIF.a is equal to 6, VIF.b equal to 4 and display statements end task, end class. Okay. This is how we can access the variables. Clear everyone till here?
Yes. Ma'am.
Okay. Next, mode port. What is mean by mode port? Mode port and locking block we write in the interface. Okay. So mode port is nothing but See the definition here. The mode port groups and specifies the port direction. Port direction. Port direction means we send the data from driver to DUT to monitor, right? So that direction we can mention in the mode port, either input or output. Okay. So it groups and specifies the port directions to the wires and signals declared within the interface. Mode ports are declared inside the interface with the keyword mode port. We use the keyword mode port. By specifying the port directions, mode port provides access restrictions. The keyword mode port indicates the directions are declared as if inside the module. Okay. So in the module, we declare the directions as inputs or reg, outputs or wire data type, right? But in a interface, we are not using reg and var data type. We are using logic data type. Okay, logic data type for both the inputs and outputs same. But how the internal system will understand which is the input and which is the output means through mode port directions. In the mode port, we mentioned the directions which are input and which are the output. Okay, so mode port wire declared that with input is not allowed to drive or assign. Any attempt to drive leads to a compilation error. Okay. The interface can have any number of mode ports. You can write for driver, you can write for monitor, you can write for generator, you can write for scoreboard. There can be any number of mode ports. The wire declared in the interface can be grouped in many mode ports. Mode ports can have inputs, outputs, inouts, reference, any values. Okay. So this is how we write the mode port. Declaration of mode port interface II. Within the interface, we declare inputs and outputs with logic data type. And then we write the mode port. One is for driver, one is for monitor. Can you tell me why we are writing only for driver and monitor? Why not for generator and scoreboard?
Not connected to interface. Only driver and monitor is connected to interface.
In the DUT side, DUT side, we connect interface to driver and monitor only, right? That's why for signal declaration, we use mode port from driver and also in monitor. Or else you can use only driver also, not a problem. No need to write for monitor. And if you want to write for monitor, we can. Okay, I will tell you the signal directions also. I will explain in the code. Next, coming to the clocking blocks. What is mean by clocking block? Clocking block is mainly used for timing and synchronization purpose. Okay. If you see here, System Verilog adds the clocking block that identifies clock signals and captures the timing and synchronization requirements of the block being modeled. A clocking block assembles signals that are synchronous to a particular clock and makes the timing explicit. The clocking block is a key element in a cycle-based methodology, which enables users to write test benches at a higher level of abstraction. Simulation is faster with cycle-based methodology. And depending on the environment, a test bench can contain one or more clocking blocks. That means we can write for driver, we can write for monitor, we can write for coverage, like that. But mostly we write for driver and monitor only, because in interface only those two are connecting with the DUT, right? So we write for driver and monitor. And also these operations are followed as synchronous events, input sampling, synchronous drives. So this is how we write the syntax for clocking block. Clocking, name of the clocking block is the CB @POSH clock. You can write @POSH clock or negate clock, whatever. And skew. Do you know about skew? Skew is nothing but sampling rate. So here we are writing default input skew, which is sampling rate. You can write a minimum delay also, like 1 seconds, 1 nanoseconds, or 10 to 2 nanoseconds. Input side is 10, output side is 2. In Verilog HDL, we write the time precision. If you know about time precision, time units, right? Same here, we mention the skew, nothing but sampling rate. And also we write the input output declaration and clock. Okay. So here is the skew. What is meant by skew? If an input skew is specified, then the signal is sampled at that particular skew time units before the clock event, whether positive or negative. If output skew is specified, then output or in-out signals are driven skew time units after corresponding the clock event. So just at what time the input and output need to sample. That's what we are mentioning here. So particularly according to the delays, it will be working. A skew must be a constant expression and can be specified as a parameter called default input and output. So this is how we write the clocking block. Clocking block, name of the clocking block, at the rate of positive clock or negative clock, default input, time units, output time units, and declaration of input outputs, and mode port for driver, mode port for monitor. Okay, understood conceptual wise? And delays, how we can mention? We can mention with the 1 hash, second 2 hash, or 1 step, like that. Clear till here? Any doubts? You need to practice. Most confusion topics these are.
Like in the last part, you said input skew and output skew. So like this thing, how to mention in the code, it's a delay or
You need to mention in the code only.
so means format is like that has, and then the delay, how much is delay is happening like that.
Yes.
And also that in Verilog code is time precision. No? So here, what is the like replacement of that time? Here the time precision we are not using.
Time precision, in time precision, what we write, precision time and the unit time, right? Here we will write directly input and output. Just a skew is used to avoid the race around conditions and improve the timing control. For that purpose, we write the input skew and output skew. Okay. So if you write default input #2 and output #3 means what? The skew will be 2 nanoseconds at the input and 3 nanosecond output. That means before clock, the sampling before 2 nanoseconds only it starts sampling, and next after the clock is output skew. So we'll get the output at a next 3 nanoseconds delay, like that, not immediately at positive edge of the clock. So all data will come at same time only with respect to the skew. And also it count the internal time. In time precision, it will not only dependent on the time scale. It will be dependent on internal times also, right? Internal delays also. So here also same, it will be dependent on skew and also internal delays. Time scale, I will share you one recorded session. Okay, fine. See here how to write the clocking block and mod port in the interface. So here is the interface and name of the interface, and passing the clock here, and all input and output variables are declared with the logic data type. Okay. Now we need to create two clocking blocks. Two clocking blocks. One is for driver, one is for monitor. Okay. So clocking Dior CB. Dior CB is the name of the driver clocking block. At the rate of POSH clock, default input #1, output #1. Here, all variables are declaring as output only. Can you tell me why we are declaring all as an output? And if you observe here in monitor, we are declaring all as a inputs. Can you tell me?
From driver side, it will go as an output to the DUT, and from monitor, it will come as input from DUT.
Okay. Okay. And also in driver, we can write outputs as inputs and inputs as outputs. Select signal and enable signals. These are inputs actually. For the design, these are inputs, but in a clocking block, in driver clocking block, we have written these as a outputs, and outputs we have written as a inputs. Okay. Coming to mod port, monitor clocking block, all signals are written as a inputs, declared as a inputs. Why? Because driver and monitor interface DUT. So whatever driver is nothing but sending the data to the DUT. Whatever the inputs are, what data we are sending to the DUT, nothing but whatever the generator is generating the input variables here. Suppose A is equal to some value, B equal to some value, or write data equal to something, write enable equal to something. Those we are sending to the DUT. So nothing but these input variables are getting out from the driver. These are output variables of to the driver. So whatever the inputs A, B, C, or write enable, read enable, write data, write address, whatever there, those are inputs to the driver. So coming outside the loop. So these are written as a inputs, and whatever the inputs are there, those are the outputs to the, inputs or outputs, outputs or inputs to the driver. Okay. But coming to the monitor, after getting all this data, DUT will do the functionality and it will send the data, input data and output data, everything we will monitor here. So all input and outputs are sending from DUT to monitor. So these are inputs to the monitor, right? This is the direction. So you need to understand the direction. So that is why we are mentioning input and outputs here, and in the driver and in the monitor clocking block. Okay, clear? Output in the driver, input in the monitor. And mod port. This is how we write the mod port. Mod port, name of the mod port. Actually, in mod port also we need to declare all inputs and outputs, but already we have declared in the clocking block, right? So that's why directly this clocking block name we are putting in the mod port. Okay, clear? Now, how to write the interface? Any confusion or any doubts? Hello, fast.
No, ma'am.
So now whatever the variables you want to access, inputs and outputs of these clocking block, how can we access, like using the interface name calci if dot request 1 command, request 2 command, request 3 command, like that we need to access. But in class based verification, these we need to access in the driver only. Okay, so in driver, but driver is a class, right? As we discussed before, we cannot access the interface directly in the classes. Okay, so to access those variables, to access these interface variables, we need to create the virtual interface. Through that virtual interface instance only we can access these variables. Okay, so in the driver, if you observe, fourth line, virtual, created as a virtual. Calcif is the name of the interface. Okay, dot Dior BFM is the name of the clocking block which we have written in the interface. Okay, mod port. Dior IF is the name of the clocking block. Here I just kept a path. Okay, wait, I will show another one. Okay, see here, virtual APB int F. APB int F is the name of the interface here. If you see here, interface.sv block. In APB int F is the name of the interface. So in the driver block, we are creating APB int F and APB VIF. APB VIF is the name of the virtual interface. Okay. Now, DUT, what is meant by DUT here? Whatever the transaction data here, A, B, C, all these are transaction data. That means we write as a tr.a, tr.b, tr.c. That means transaction.a, transaction.b, transaction.c. We already written the transaction class, right? This is what class transaction. Here we need to declare the variables, we need to write the constraints. Okay, how we can access these variables in the transaction class? Same, through the object only, through the instance only. Okay, so transaction instance, suppose if we create as a tr in any class, we need to access through tr.p address, tr.p write data, tr.write, tr.select. Okay, so that's why I have written here tr.a, tr.b. So this tr.a, tr.b, we need to send to the DUT via virtual interface. That means VIF dot a, VIF dot b, like that. VIF dot a, VIF dot b. So to this virtual interface, we are passing tr dot a, tr dot b. Okay, that is what driver to DUT. Coming to DUT to monitor, how? Here we will have the virtual interface data. VIF data is the right side. We need to convert that virtual interface data to transaction data. Okay, so that's why VIF data will be sent to the transaction data. That is what the path you need to understand. Okay. So if you observe here in the driver, so right side, 65th line, I'm not explaining all. 65th line, if you see, tr.p address is equal to this macro dribf dot p address. What is this p address? This macro. So if you see here, macro, this is what the path of that macro, first line. dribf is the name of that macro. APB VIF is the virtual interface. Dot driver is the mode port. Dot driver CB is the clocking block. Okay. So go to the interface. We need to access these variables through the virtual interface name dot mod port name dot clocking block name dot p address. Okay, like that virtual interface dot mod port name dot clocking block name dot these variables. Okay, same path here we have written. Okay, DRIF is the name of this macro. We are accessing these particular variables. What variables? P enable, P write, P address, P write data, again P enable. All these variables we are accessing through this path. Actually, instead of putting that, you need to put all this entire path in every line. This. Instead of this, you need to put like this. Whole thing for every line. So without putting that, directly we have created the instance here, path here. Through that macro name, we are accessing these variables. Did you understand now, everyone? Any doubts still here? So in the driver, if you see TR data, we are sending to the virtual interface. Coming to the monitor, we need to get the virtual interface data to the TR. So left side is the TR variables and right side is the virtual interface variables. That is what that virtual interface declared here. For monitor also same path. Don't worry, it takes some time to understand. Okay, as of now, just understand what is meant by interface, virtual interface. That's it. Okay. Any doubts still here? No? Clear?
Yes, ma'am.
Okay, I will share the assignment. Maximum, I already shared the semaphore assignment. Work on that. And for interface, practice these examples. Okay, so that's it. Next session on Saturday. Okay, Saturday we have protocols. Bye.
Okay.